So that's it for the print int array using pointers. Knowing a pointers is just a variables that takes its value from the memory addresses. Now, the print in reverse function. This is the functions that displays that print in reverse. It displays an integer array in the reverse order. I'm going to comment out this function call. Let's rewrite the same function again, but this time using pointers. The print in reverse function receives an array of values and the length. So we know the starting address of the array, knowing that the name of the array is a pointer or is a pointer that contains the value of the first elements of the array. We know the starting address, we know the length, so we can determine the last address of the last elements in the array. Let's delete all of this. Okay, so we're going to use the same approach, starting address, or I'm going to name the variable starting address, or just simpler, I'm going to name it start. Okay, start. Now we have the end of the array. The end of the array is the start plus the length. So we know the starting address. We add the length to get the address of the last elements, knowing that each element in the arrays has an address. We're going to also create a pointer that we call currents. The current address at which we are and we want to display. So I'm going to call it like that. And set it to the start. Now let's loop through, let's use a for loop. For the current address equal to the start and the current address difference or lesser or equal to the end, we want to increment the current address. So we move on the next address. We're going to use the printf function to display the value at each of these addresses. We know that the current address and let's use the dereferencing operator. That way we're telling the compiler we want you to display the value of the address stored in this variable. And at the end, we display a line break. Let's run the same code and see what happens. Print array in reverse. Oh, sorry. That was basically the same as the previous one. We had to display the array starting from the end to the start. Okay, so here I'm going to change the conditions. I'm changing the conditions. Instead of starting the currents, we're going to start it from the end address. So we start from the end. Using the for loop, we say for the address starting from the end and the current address greater or equal to the start, we want to go back, so current minus minus. Then we use the printf function to display So here we are not displaying the contents, the value of the variables, but we're displaying the value of the address stored in the variable. So we use the dereferencing operator. Great. So that's it. We're looping from the last address of the array to the start of the array, then we displays. Let's execute this code. GCC main.c, then print in reverse the O option for the output file, execute. So now we have something displayed here. We see that it displays 16, 10, 9. And what is in our array? We have 10 elements. So here we shouldn't have 16. There is a problem. Maybe a miscalculation of the last address. Yeah, we had to say start plus the length minus 1 in order to get the last address, because an array um, uh, for the indexes, it start from 0, 1, 2, 3, 4 till the length minus 1. So in order to guess the length of the address of the last element, we had to use length minus 1. Great. So let's compile this code again. Now it's displayed the correct output, 10, 9, 8. I'm going to pause from here and return into the print string, because I think we print int array. I think we did the same error here. We had to put in a -1 for the last address. And here we have to say lesser or equal to the ending address. So that is the correct way of doing it. It is much more understandable. We know the last address, and from the current address to the ending address, we display the contents. Great. Let's go back in our print in reverse. So the print in reverse, we're done with the print in reverse function. Next, we have a string of character. We want to use addresses or pointers to display the string of character instead of using the square bracket notation. How do we do that? I'm going to uncomment this line of code here. We're declaring a string of character. So a string of character is simply an array of character that ends with the null character. And let's rewrite the print string function again. Inside the print int string function, I am going to delete the code in here. So it is basically the same thing, but here we don't know the address of the last elements in the array, but we can loop through the array using pointers. So let's create a pointer called current. It will start from the first address of the strings. And we say, while the current address, while the value stored in the current address, do not forget to use the dereferencing operator, is different than the null character we want to display. So I'm going to use the character format and the dereferencing notation, and we move to the next one. So here we're using the addresses. We know the address of the first elements in the string or in the array of character. And we have to use the dereferencing notation to check every time what value is stored in the specific or the current address. And we display, then we move to the next address. Let's run this code to see what happens. It will have the same output as usual. gcc main.c, then prints string.c. The output file name will be main. Yeah, it is the same output, but this time, instead of using indexes or the square bracket notation, we're using the addresses and dereferencing to display the values. Let's do the same thing for the print string in reverse. I'm going to return in the main function and comment out this line, the print string line. Now, the print string in reverse. For the print string in reverse, we had to find out the length of the string because we cannot display a string in reverse without knowing the address or the positions of the last elements in the string. We had to know the last address first. Then we loop from the last one to the start. Basically, nothing changed here. Apart from that, we're going to change the notation. So we knows where the string start, the starting address. Let's go back in our drawing tool. So we have the starting address. We know the starting address, but we don't know where the string stops because the length has not been provided. We have to find the length by ourselves, or we have to find where the strings stops by ourselves. And we do know that all strings should end with the null character. This is the information we're going to use to find out what is the last address in the strings. Now, back in the editor, let's find out what is the last address. So I'm going to create a variable called the end, or just call it the start. The start will take the value of the first, the address of the first elements. And we also have the end. But the end, we don't know it yet. We don't know it yet because the length, we don't have the information about the length. If we had that, we would just type in something like length -1, but we do not have this information. So we'd have to find it by ourselves. What we're going to do, I will initiate, or we're going to initiate the end to null. This is important. Every time you define variables, it's always good to give them an initial value. We're not required to do it, but it's a good practice to provide an initial value. In the case of the pointers, we use null. Next, we define a variable called current. This will store the address for the current element or for the current character. Do not forget that a string is just an array of characters. So let's find out what is the end. So finding the last address of the last element. Uh, for or for the current, I'm going to set it to start. So we're going to start from the start, the first address. So while the current value, while the value in the current address is different than null, we are going to move to forward. Great. So when this loop ends, we know that we are at the end of our array. Or maybe there is other way. I think that people's might understand it much easier. Let's just declare a variable called length. So we're going to find out the length, then we determine the last address knowing the length. So here we are using pointers. Length plus plus. So every time we can move forward, we know that the length will increase by 1. Great. Now let's define or let's determine the last address. The last address will be the starting address plus the length minus 1. Great. So we know the last address. We also know the first address. What we'd have to do is to loop backward because the function want to display the strings in reverse order. We're going to loop backward. So I propose to use the for loop. So for the current address starting from the end, and the current address is greater, and while the current address is greater than or equal to the start address, we're going to go backward. Then at each address, we are going to display the character. Here we use the dereferencing operator, so the asterisk. I'm going to add a command here, display the string backward. So here with current, the pointer, or we start from the last address of the strings, and we go back. So as long as the current address is greater or equal than the starting address, we can still go back. If you look on the drawing tool here, so we're starting from the last index and we stop when we hit on the first index or on the first address, the last address to the first address. Let's compile this code and see what it does. GCC main.c print string in reverse. The output file name will be main. I'm going to execute the code again. And here we are. We see that we have the L and the K, G, F. So now instead of A, B, C, D to L, we have L, K, G to A. The string has been displayed in reversed order. So this is the part where we know how to use pointers or addresses to loop through an array, because when we know the first address and you know the last address, we can just increment um, one by one till the last address and displays using the dereferencing notation to display values at specific memory addresses. Great. There is something to know about the str. Usually when you want to display a strings, you don't always you would not always want to loop through the strings or the list, the array of character. There is a way to display the string directly without looping through it, but using the printf function, just keep in mind that we can still display a string like that with the printf function, like that. So we have the former and we have the string. The printf functions knows that if it read the former, it knows it's the strings, and it will also know it's an array of characters that end with the null character. It will use the same kind of logic we used in the print string functions to display the strings. So you might use these functions more often than your own custom function to display the print string, the string, a string. Next, after that, we knows how to display a string in um, in the forward order, and we knows that how to display it backward. The next thing is how to reverse an array and how to reverse a string. That is interesting. We're going to end on that, reversing a string or reversing an array. I'm going to comment these things out. Let's start with this. We want the first thing we knows how to display the string, the array, and now we want to display it in reverse order. No, we want to reverse the array. We want to reverse it. How do we do that? Let's create a file called reverse array. So here we are. I'm going to define the prototype. It will be reverse array. Reverse array. This will take an integer array like that. Let's say an array, and the length of the array. So what should this function do? It will take the array and move the values around. So the first values or the first element's value will be the last element value. It will change the positions of the values. Let's look into this one and how it might help. I'm going to draw. So we have values in the array. Now we want to, let's say A here, and B, C, D, and E. Now the resulting should be the E will come here, the D will come here, and the C for this particular array won't move. We can do that. So the question is, let's say you want to swap the value of two variables. How you do that? You can take a problem like that. You have a glass of water, and a glass of milk. Now we want you to swap the contents of these two glasses. How are you going to go about that without pouring the contents on the ground? So I'm going to draw something like this is the glass of water and this is the glass of milk. Now we want to swap their contents without mixing them and without pouring the contents on the ground. So one basic thing is that you cannot swap their content without mixing them. Logically, you would need a third glass, a third empty glass, where you're going to store, for example, you can say we're going to pour the contents of the milk of the glass of water in the empty glass, then pour the content of the glass of milk uh, in the glass of water, because now the glass of water is empty. Then now that the glass of milk is empty, we then pour the content of the third glass into the glass of milk. So we've been able to swap the contents of the glass of water and the glass of milk by the means of a third glass, a third empty glass. That's exactly what we're going to do with the arrays. We're going to add here a pointer. We know the start. We're going to add in here a pointer, and we're going to set a pointer that points to the last element of the array. So at each loop round, we swap the values of the addresses. Let's go back and see how to do that in the code, so it will be much easier. Let's declare a variable called the start, or let's call it the front. Yes, this will be the front. We'll set it to array, and we are going to create another variables called the back. The back will be the front. So the start plus length -1. So here, we know the starting address, then we know where is the last address by doing this calculation. We know the front, now we know the back. Let's swap their contents. How do we go about that? We can say, while the front is lesser or equal to the back, while the front is lesser than the back, we are going to swap. Let's say the front move forward and the back move backward. But before that, we're going to swap. As usual, we're going to declare a temporary variable where the values are stored, meaning the empty glass, as in our drawing. This will be our empty glass, and we're going to set it to 0 because it's good. It's a good practice to set a variables to an initial value when you create it. So we take the value in the front, we save it in our empty glass or our uh, temporary variable. And now that the front value is saved in the temp, we can override it by the value of the back. So we use the start sign to tell the compiler we want to replace the value look in the address, at that address. So we add in the back. We assign the value stored in the address of the bag and to the address in the front. Then now we're going to set the bag to the value of the front. So this one is the temporary variables we declared here is important because if you assign the value of the back to the front, you will lose the value of the front. So that's why we have to declare a third variables where we save the value of the front before overriding the contents. Then the saved value can be assigned to the other variables or the back. So that's how we reverse an array of character. An array, generally speaking. We know the length, we know where the starting address is, we know where the ending address is, and now we can swap. For the condition in the loop, front lesser than back, that's because, let's go back in our drawing. When you're moving the pointers, you're moving the starting the the front pointer to the end, and you are also moving the the back pointer to the start. At a point in time, they will meet. So when the front pointer become greater than the last the back pointer, and the back pointer becomes uh, lower or smaller than the front pointer, that means you should stop, because if you continue, you will reverse again, reverse, you would undo what you were doing. So it will have no effect. So that's why in the while loop, we always want to say, make sure that the front is lesser than the back, or the back is greater than the front. So we want to cancel the change we did while reversing. If any question, people can ask in the chat or just interrupt. Great. Let's test this function and see what happens. I'm going to copy, we're going to copy the prototype and save the prototype in the main.h file. So the compiler knows how to use the reverse array. Then here we're going to call the reverse array. Reverse array. We pass in the values and the length. So now we after this call, we have to display, or we want to display the array. For that, I'm going to declare a variable called here index and initiate it to 0. This will be our variables. And so we don't have to use the loops in the main file because we already have the print int array function. We can directly use that. No need to do the same things again. So here we call the print int array before reversing. Now we are calling the print int array after reversing. Let's see what will display. GCC main.c, and we have to specify the print int array and also the reverse array function definition file, and the output will be main. Now let's run. And as you see,